Namaskaram. Welcome to the course Basics of Electronics. In this video, we will be knowing about digital to analog converters in electronic industry. This video is divided into four important parts. First one is what are DACs and how does they work. Second one is types of DACs and their significance. Third one is applications of digital to analog converters. Last but not the least, fourth one is advantages and disadvantages of digital to analog converters in electronic industry. So let's begin. What are digital to analog converters and how does they work? Digital to analog converters are the electronic integrated circuits which are responsible for converting digital signal into analog signal. They consist of a decoder and also an operational amplifier, which is responsible for converting a digital sequence of data or a digital sequence of bits into analog reference voltages, which are useful for driving the variable actuators which are used in industry most of the cases. Let us consider a couple of examples to understand how DACs are used in real world. First one is audio system or maybe a speaker. When we are understanding with the speakers or audio engineering, we know that all the information is stored in the form of digital format inside the memory bits or maybe a memory devices. Now we want to reproduce that particular sound by using that memory. Then we need a digital to analog converter to convert that digital data into analogous voltage. Then that particular analogous voltage is given to the speaker system or amplifier to reproduce the sound or vocals that are stored in the form of digital data. That's how DACs are used. Another example would be speed control of a DC motor. A specific analog voltage for the DC motor will create a specific RPM. To generate a specific RPM, we can use the digital to analog converter to convert the specific digital combination of input into a specific analog voltage. This is how the most of the industrial motors are controlled by using an embedded system and then digital to analog converter to convert that embedded system output, which is a digital format, into analogous voltage and then given to the driver circuit to drive the heavy motors. Types of digital to analog converters and their significance. Basically, there are two types of digital to analog converters in electronic industry. First one is weighted resistor digital to analog converter. This particular circuit uses the weighted resistors inside along with the inverting adder. Because of a variable resistance sequence, it can create a variable voltage at the input of inverting amplifier. Then it will generate an analogous voltage at the output side. If we use a 3 input bits, then we can create a 7 variable analog voltage at the output side. It is very difficult to calculate the resistance value and create a circuit inside this particular network because it uses a specific resistance for a specific input voltage. As number of input increases, this circuit becomes very complicated and very difficult to calculate the specific resistance value and procure the specific resistance value when you are designing a hardware in real time. Second digital to analog converter is R2R ladder based digital to analog converter circuit. It uses R2R ladder and an inverting amplifier or inverting adder circuit. That's why it is called R2R digital to analog converter. The fundamental reason why it is so called R2R because it uses only 2 value of resistor in the entire design activity. For example, if you use a 1 kilo ohm resistor, then another resistor would be 2 kilo ohm, and throughout the circuit, this combination repeats for the n number of bits that we going to add. If we use a 3 input bits, then 3 combination of R and 2R resistors are added in the entire circuit. Because of which it is very easy to design, very easy to procure the component for the design activity, and also very easy for the calculation of the output voltage. This digital to analog converter circuit is more accurate than the weighted resistor digital to analog converter because of resistance value tuning and also because of the kind of circuitry we are going to design in this. These are the two types of digital to analog converters which are widely and fundamentally used in entire electronic industry. Applications of digital to analog converters. There are numerous applications about digital to analog converters in electronic industry. However, here are the 4 example applications for your understanding. First one is music players. As I already explained about how speakers and amplifiers are generating an analog voltage with respect to digital to analog converter in the previous part of this video, this is very essential example or application of digital to analog converters. Because any data that is stored in the memory needs to be converted into a form of analog voltage to drive the speaker. For that purpose, we use digital to analog converter circuits. That's why DACs are very popular in audio engineering or speaker systems. Second application is brightness control applications in screens or in LEDs. Whenever it comes to controlling the brightness and intensity of a light, we need a circuitry which will convert our digital input into analogous voltage, which will drive and control the brightness of LEDs. That's how the digital to analog converters plays a vital role in converting a human entered value in the form of digital data into analogous voltage to drive the brightness of LEDs or TV screens or laptop screens or maybe a mobile screens. Third application is wired and wireless communication. As we already know about the communication industry growing like anything, and every device around us is having a wired or wireless communication between other devices nowadays. That's how digital signal is being processed into analog format and then transmitted, and then analog signal is converted into digital signal by using a ADC in the receiver system. That is how the digital to analog converter and analog to digital converters are widely used in communication industry. Fourth application is speed control of industrial motors. Again, we have spoken about this particular example in the beginning of this particular video. However, speed control of a servo motor, speed control of heavy duty motors inside industry is driven by digital to analog converters. Human machine interface inside this particular industries are having a digital controlling or digital computing devices like embedded systems or IoT devices, which will generate a data in the form of digital bits. And then those digital bits are given to a circuit which will convert that digital data into analogous variable voltage. Then that particular voltage is given to the drivers to drive the speed of this particular motor installed in industry. So these are the 4 example applications for your understanding with respect to digital to analog converter in electronic industry. Advantages and disadvantages of digital to analog converters. Let's talk about the pros and cons about the digital to analog converter circuitries inside electronic industry. First one is advantages. First advantage is digital to analog converters improves the audio playback quality by means of bit resolution and accuracy. When we convert our audio signal in the form of digital data, we can process that data much better way using the computing devices, which is called digital signal processing. After that, we can play back them with a high bit resolution and also more accuracy than before by using a digital to analog converters. Second advantage is R2R ladder based digital to analog converters are easy to implement and widely used in electronic industry. Because it uses only 2 resistor combination and a very few components around them, it makes designer easy for the designing a required circuit for the conversion of digital signal into analog signal in electronic applications. Third advantage is it creates an immense possibility for a designer to create a circuit for generating various signal patterns. In case of a generation of a square wave, sawtooth wave, triangular wave, pulse waves or sinusoidal wave, we can literally generate all kind of waveforms by using a digital to analog converters and feeding a digital to analog converters with the digital data generated from microcontrollers or microprocessor. It's like creating a own signal by using a digital programming. Fourth advantage is modulation and demodulation in communication system. Digital to analog converters plays a vital role in the modulation process of any signal into an analog signal which are suitable for transmission. That's why digital to analog converters are widely used in transmission system in the communication industry. Now let's talk about the couple of disadvantages of digital to analog converters. First disadvantage is no zero output voltage because of resistive network. Resistors are having a very sensitivity with respect to the temperature or maybe various environmental factor around them. We cannot set the output voltage of these digital to analog converters to 0. Second disadvantage is these digital to analog converters require very great amount of analog design engineering system or analog design engineering expertise to design a circuit with low noise. Third disadvantage is non-monolithic behavior due to integral non-linearity, which means if you expect a X amount of factor raise in the output at the output side of a digital to analog converter, because you have increased X amount of input circuitry, it doesn't work like that. The linearity of input to output ratio is not constant for all stages of the digital to analog converter. That's why it becomes very difficult for predicting the output voltage when you are not having a proper design engineering in the hardware designs. Fourth major disadvantage is these digital to analog converter circuit uses the expensive operational amplifiers for the better efficiency, which makes the entire circuit more expensive to use in general electronic and general applications. So these are the 4 advantages and disadvantages of digital to analog converters in electronic industry. This is all you need to know about digital to analog converters in electronic industry. I hope you enjoyed the detailed walkthrough about the entire DAC circuitry inside electronic industry. See you again in the next video. Until then, happy learning. Namaskaram.